Hello students, today we are going to discuss about displacement reaction. So before this one, just I would like to remind you, during last classes we had discussed combination reaction and decomposition reaction. Today will start displacement reaction. First of all, I would like to define what is displacement reaction. So those chemical reactions in which more reactive metals or non-metal displaces a less reactive metal or non-metal from its aqueous salt solution are called displacement reactions. We can take a simple example to illustrate it. That is, when a compound of AB react with C, then it forms a compound of AC and B is separated out from its aqueous solution. So this is the example, and here students you see AB reacts with C to form a compound AC, and an element B, it is because element C is more reactive than B. As a result, it is displacing B from its aqueous solution and it gets separated out. So here C is more reactive than B. Now the very important thing, one question arises here, that how to know that which metal is more reactive and which is not. Really, how will know that which one is more reactive and less reactive? So students, first for this one we'll have to know the reactivity series, and we'll have to learn it by heart. It is very important. Reactivity series. So what is reactivity series? The series of metals in which they are arranged vertically in order of decreasing reactivity from top to bottom is called reactivity series. And how we will learn this one? What are these? To see, here it has been given the elements. See the elements, its symbol, and learning technique also I have tried myself, and then you should learn this one. It is heartily. So element, symbol and learning technique I have written here. So these are, first one is potassium potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper. Hydrogen is not a metal, but it has been taken in the reactivity series. And mercury, silver, gold and platinum. Here students, here that is potassium is at the top, that means it is the most reactive metal, and here platinum is at the bottom, that means it is least reactive. It is least reactive, whereas potassium is most reactive. It is most reactive metal. Now the technique I have tried, that is, you will have to learn it by the one mantra, that is केदारनाथ का माली आलू जरा फीका पकाता है, क्यूट हरी आएगा और पीटेगा. That means Kedarnath, from first letter it is K and Nath, first letter is N, then for sodium, Ka. So you will have to learn students, Kedarnath का माली आलू जरा फीका पकाता है, क्यूट हरी आएगा और पीटेगा. Again, once again, केदारनाथ का माली आलू जरा फीका पकाता है, क्यूट हरी आएगा और पीटेगा. So this is student, this is the technique, and it is you must learn it by heart. Now we will discuss some examples of displacement reactions. Here number one, more reactive metals displaces less reactive metal. So here more metal, let us see the examples where more reactive metal displaces less reactive metals. So see here, zinc react with ferrous sulfate, and here zinc is more reactive than ferrous. In the reactivity series you will have to decide which one is at the top. So you will find zinc is at the top, hence it is more reactive than iron, and zinc will displace iron from its aqueous solution, and it will iron will get separated out. Next one, here students, this color are also important. You should learn it also. It is a light green and it is colorless, and it is blue, it is colorless. How change in color takes place, you can see here. So these are also very important, which color gets changed into which. So see here, next one is magnesium when react with copper sulfate. Copper sulfate color is blue. So here magnesium is above copper, that's why very clear it is that magnesium is more reactive than copper, and copper will get displaced by magnesium. As a result, the here copper will get separated. In the same way, see students, all these are the examples you should go through. We'll discuss that this ferric oxide when react with aluminium, it forms aluminium oxide separating out iron, and large amount of it, due to this large amount of it, which is approximately 3000 degrees Celsius, due to this temperature, this iron produces in molten form, and this molten iron is used to rectify railway lines, and this reaction is called thermite reaction or thermite welding. These are some examples students you can see of displacement reaction. Now we'll see some example of displacement reaction where hydrogen is displaced by metals. These are some examples where hydrogen is being displaced. In every reaction you can see hydrogen is being displaced from its solution, aqueous solution, and this is these are some example of displacement reaction where hydrogen is being displaced by metals. Now we'll see some example in which the non-metals displaces another non-metal. See here, chlorine when react with potassium bromide, it displaces, chlorine displaces bromine, and it gets displaced. In the same way, here also you can see bromine is more reactive than iodine, and it displaces iodine. Chlorine is more reactive than iodine, and it also, the chlorine displaces iodine. Now students, we'll discuss double displacement reaction. First of all, we should define what is double displacement reaction. So those chemical reactions in which exchange of ions takes place when the aqueous solution of two ionic compounds are mixed together. This is called double displacement reaction, and this double displacement reactions are characterized by formation of solid product, which is known as precipitate, which can be represented by PPT. We have discussed already. And these, one more thing, these reactions generally takes place in aqueous solution. See student, some examples has been given here, and in this example, take one example like silver nitrate when react with sodium chloride. After reaction they form silver chloride and sodium nitrate. In this reaction you can see it is very clear that they used to change their partners. Here before reaction silver was combined with nitrate, but after reaction this silver has combined with chlorine and sodium has combined with nitrate. So they have exchange their partners. See these are some examples, students. You can you must learn it. You must keep in your mind these examples, reactions, and see one example we can take. When barium chloride react with sodium sulfate, so this reaction we can this is example of double displacement reaction, and we have just discussed that double displacement reactions are generally ionic reactions taking place in aqueous solution in which ions participates and there is an exchange of partners or ions. They used to change their partner. Actually these partners are their ions. So you can see this example in the form of ions. And for this example we can do this experiment. For this experiment we can do one activity, and in this activity we should do the activity, and we should take an aqueous solution of barium chloride in a glass tube, and in another tube we should take an aqueous solution of sodium sulfate, which is both are colorless actually here. And now add sodium sulfate solution dropwise to barium chloride solution. A white precipitate of barium sulfate is immediately formed as a result of double displacement reaction. And you can see here, this one we have represented here by separating their ions, and how after a reaction they have changed their partners, and after reaction they have formed barium sulfate, which is actually a solid, and this is its color is white. Thank you, students. Have a nice day, and stay home, stay safe.